and it's a wonderful sunny morning. It's the 15th of April, and lockdown, the first part of it is over anyway, and we can get more freedom. And as you can see, I've just come back from having my hair cut. It was getting a real mess, but now I feel 10 years younger. Anyway, it's good to get it done. And this video is going to be about finishing off the AVO vol tester. You may wonder why I'm not in the workshop. Well, I'm going to be in a few minutes, but I thought I'd make the introduction to this video outside because it's a lovely sunny day. It's quite warm. One of the things that we needed to do with the vol tester was look at the neon indicator. Since the last video, I've managed to get hold of a neon, and that is now fitted, and a little cover for it. I've also been doing some research into the circuitry regarding the use of the neon for short circuit testing, and that took me into the realm of looking at neons and strike voltages and things like that. So before I start the actual workshop bit, I thought I'd go through the neon circuit with you outside because it's nice. The other issue that we had, or I had with the vol tester, was the little plugs that plug into the anode grid and screen sockets, and also to the continuity sockets on the tester itself. Now these sockets, these little plugs, had me mystified. They weren't banana plugs, they weren't phono plugs, and my research found out that they were called wander plugs. Now back in the day when I was an electrical apprentice, we used to use wander plugs all the time, and when I actually found out what they were called, the whole memory came flooding back to me. Wander plugs, we used to use those a lot, but now they're like gold dust. You can buy them on eBay, but they're quite expensive, and there are some companies that send so-called wander plugs to you actually end up sending banana plugs. Now the plug sockets on the vol tester are actually 3mm. They need 3mm plugs. Wander plugs are 4mm, but you can get 3 ones, but they still don't fit because of the bulbous bit of the banana bits on them. But I've discovered how to make a 4mm banana plug into a 3mm wander plug, and it works absolutely perfectly, and I'll be sharing that with you in a minute as well. But first of all, let's have a look at this circuit for the neon indicators on the vol tester, and we'll have a little look at that and a bit of explanation, and then we'll go into the workshop. So let's do that now. I'm just going to deal specifically with this part of the circuit for the neon indicator on the AVO vol tester. You can see there's a 230 volt tapping on the transformer, which goes directly to the neon. It also feeds a 250k resistor here, and on the return circuit another 250k. So making 500k altogether in series with the neon from the mains. If you follow the circuit through, we come to a switch socket which is on the top of the AVO meter. That's the left hand socket, and then we have then it goes through a switch which is normally closed on the right hand socket and through another 250k back. Now the handbook says that you can, well, quite rightly, when you power up the AVO meter, the volve tester rather, the circuit flows through these series resistors, and the neon strikes because it's below the striking voltage, excuse the train, and the neon lights indicating that the machine is turned on. It recommends that you use this neon for a short circuit tester, so that if you plug a wander plug in there, in my case it's going to be a modified banana plug, and a wander plug in there, when you plug that one in, it opens that circuit. So the only way that the circuit can flow then is through the circuit external to this, whatever it might be, a valve or a continuity test of some sort, back into here and through the neon. Obviously, if there's a short circuit between these two when that's open, then the neon will light. If it doesn't light, you know that the continuity, there's no continuity, and that the test is okay. Now the valve tester recommends that you use it to check check the heaters on the valve. Obviously, although it's 230 volts, the current is very, very small. It's limited by these two resistors, and they also recommend checking between the anode and the grid on the valve to see that there are no shorts before you actually test the valve. If you try and test the valve and there's short circuits internal to the valve, then it could damage the valve tester as a whole. So that's the setup. The neon is now fitted to the tester. I've made a couple of these modified banana plugs into Wonder plugs, so I should be able to do continuity through this and through there, and we'll see how it all works. So that's the basic circuit. So now let's go into the workshop and I'll show you how to modify the banana plug, and we'll also do some checks on voltages and things around this neon circuit. And that's it. I think once that's done, the valve tester is finished. Well, this is the Wonder plug. I remember them from many, many years ago. It's a very simple thing. It's almost like a split pin with a wire wound around the junction at the top, and a little brass capture screw that the top goes on. So that's basically what a Wonder plug is, and they measure 3 millimeters. Well, I've now got my calipers across the Wonder plug, and you can see it's measuring 3 millimeters. So that's the size we want to try and achieve. Now let's have a look at the banana plug. Banana plug, so called because of the bulbous strips, that lead to the tip of the plug, and those can be depressed, and that's a banana plug. That one measures 4 millimeters across. Well, there's a banana plug in the calipers, and that's measuring just a fraction under 4 millimeters across. So what we want to do is reduce that till we get the same size as the Wonder plug. So let's do that. So what I'm going to do now is saw down each of the 4 banana flares on this plug. At this point you can see that the flares have come away from the center shaft, so I'm going to take that out now and then remove them. Well, these shots show the banana clip with the outer casing being removed, and the final one with the outer casing completely removed, and leaving just the center shaft of the banana plug. Well, there's a picture of the calipers on the banana plug with the banana clips removed, and you can see it's measuring 2.99 to 3 millimeters, which is exactly what we want, which emulates the Wonder plug absolutely. So let's try it in the meter now. So I've got my modified banana plug, and here it goes. I'm going to put it in there, and it should fit perfectly. Absolutely great. And it's got quite a lot of tension on it as well, so it's a good fit in there. In the other hole, where the switch is attached to it, as we talked about earlier, you put it in, but to disconnect the neon you have to push it down, and you see it's on a spring. That's it all done. There are the 2 leads simulating wander plugs ready to plug into the neon test circuits of the valve tester with crocodile clips on the end. So quite pleased with that, and that's all done. I'm going to keep the original screen and grid wander plugs on the socket side of the valve tester because they are original and they do work very well. So I'm going to keep those. But let's now go back to testing continuity using 230 volts and the neon. Well, there's the valve tester powered up, and as you can see, the neon indicator is working, and that's absolutely fine. I've got my two plugs in for the continuity test, and the manual does say that before you test a valve you need to do a short circuit test using this. There are my two wires coming out. I've got them terminated in crocodile clips connected to the meter. The meter's not reading anything and the neon's on. If I press this one down, you should see the meter read and the neon go out. So I'm pushing it down. So the meter is now reading 168 volts AC, and the neon is just barely glowing. That's because of the resistance of the meter, and it's still able to strike. If I disconnect the meter now, take this off, and pretend we're doing a continuity check. So the meter is now on. There's no danger of me touching these at all because that one's not pressed, but even if it was, the current is so low that it's not going to make any difference. Or it is lighting slightly, and it's bound to because of my body resistance. And you may say, well, I'm not connected to ground. No, but it's going through me. It's only a very low current going through, but it will check continuity and short circuit. So for instance, if I put it across, I don't know, what shall I put it across? Well, if I just short circuit it, push that down, short circuit it, the neon comes on, showing that there is a short circuit. And it's very sensitive because if I go across it, it's now showing leakage through me. So if there is a leakage in the anode to grid connection within the valve, it will also show that neon will light slightly. So there shouldn't be any at all. So let's try that now on a valve. It's now connected to the anode of this particular valve, and I'm just going to check it by putting that, and the neon does light. Now I'm going to put it on the grid, and there's nothing at all. So there's no interconnecting shorts on that valve. So I now can go ahead and test it. I just thought it would be interesting to see how much current is passed on this neon check. So there's my meter on milliamps across these terminals. So I'm just going to push this now, and we'll see that the meter is reading 1.7 milliamps, so less than 2 milliamps current flowing. So no harm to anybody there, but it does give a very good indication of continuity and leakage as well. So that if I take that off again and put myself across there by holding on to these two connections and push it down, you see the neon dims a lot because it is passing some current, so it's showing leakage. So that is quite good, really, part of the valve tester. So let's come back. You can see the heater there, it's glowing nicely. I've set everything up. You must be careful with your heater settings because you could easily blow the whole thing if you have too high heater voltage on. But as you see, I've got my anode volts here set to 250, which it specifies in the book. I've got my I've got the heater volts, the screen set to 100 volts, and the heater volts set to 6. So let's come back and do some checks on the meter. Oh, just out of interest, when you start this, you must have that MAV switch set right down to the set position down the bottom, the 100 position. Otherwise you could damage the meter. So what I'm going to do now is come back and test the valve. So the first thing to do on this test is to zero the meter. So I'm zeroing it now. Hopefully you can see that. And now I'm going to push this onto its first position and then zero it again, and then push this switch to the MAV position to get a reading, and it's reading 2 MAV, which is correct for this particular valve. Now I want to do a good, that's the emission of the valve. Now I want to do a quick good bad test on it, and you can see the meters calibrated in replace and good and intermediate there. So now it says we have to set this control to the MAV of the valve, which in this case is 2. Zero it again, push this switch to the MAV position, and it should register, and this valve is registering as good. So that's it. That's the valve tested, and I'm really pleased. That's the meter, the valve tester finished. Now all I've got to do is put it back in its case, give it a final clean up, and use it to test some of my old valves, so that I've got some vintage valves tested as good, which is quite nice. And when I get my next vintage radio in for repair, then I can rule out the valves immediately by testing them. So quite pleased with that, and that's that very, very old valve tester brought back to life again. What can I say? Thank you for watching this this series on the restoration and testing and use of the AVO valve tester Mark 1. And I'd like to thank all those who have responded to me on YouTube and offered helpful advice and circuits and various other things. I am very pleased with how all this has turned out. It's been a long time coming, but I'm now happy that this is done and everything is working, including the neon. I must admit I'm going to have to do some more research on neons, because I think they're quite fascinating things. Anyway, thank you for watching. Not a lot more to say. Thank you very much for all my subscribers. I've gained a few more in the last couple of days, which thank you very much. And thank you for all those people who view my videos. I quite enjoy making them. I hope you enjoy watching them. I've got nothing to repair in the workshop. Just waiting for maybe an old radio now or something, or an amplifier, but I've got absolutely nothing. But now lockdown is over, I might be getting the odd phone call to say, Dave, can you fix this for me? And I'll think about it. Anyway, thank you for watching, and especially this series on the AVO meter, and as always, take care.